Welcome to this Introduction to Blockchain Technology, presented by Coding Bootcamps. In this presentation, we're going to discuss first and second generation blockchains. So we've already covered this information, and so far what we have covered is our blockchain networks. The way that blockchains are mined, the way that hashes work. So we also talked about proof of work and consensus. So now we're going to move on to first and second generation blockchains. So our first generation blockchains track ownership of their native tokens. So something like a Bitcoin, perfect example. Bitcoin only manages its native token and the transactions associated with it. That's it. So Bitcoin is, again, a great example of a first generation blockchain. There are no other assets on the Bitcoin application. Everything is managed. Anything that's managed is just for Bitcoin. First generation blockchains are not bad or obsolete. Blockchains have progressed to a point where now we have second generation blockchains. That is certainly more advanced. Shortly after the success of Bitcoin, different communities began to build blockchains. And of course, all these communities envisioned that there was much more that you could do with our blockchain networks. And the communities divide ways for blockchains to manage other assets besides native tokens, and also to run applications. And this is where the idea of the smart contract comes from. A smart contract is computer code, or is essentially an application that's running on the blockchain. It can execute the terms of an actual contract, but in reality, it has very little to do with a contract in that, other than that, it can enforce or carry out the terms of a legal contract. Smart contracts could reach their full level of usefulness on a blockchain because there are these ways to make payments. So the difficulties associated with making payments were eliminated by the blockchain. And the idea was first theorized long before the popularity of blockchains. The invention of the blockchain provided an ideal environment for running of smart contracts. On the blockchain, smart contracts can enforce the rules of the legal agreements and make payments to the interested parties. Again, the name sounds deceiving, but smart contracts are exactly computer programs or applications that run on a blockchain. Smart contracts are immutable once they are deployed. Now, there have been some advances in blockchain where smart contracts may run slightly differently on Hyperledger. So we can actually update smart contracts in an easier way than they're done on most other blockchain platforms. And smart contracts can be virtual versions of written contracts, just like we said. They can contain rules that, when satisfied, can release payments. Sometimes this is known as the escrow model. When certain conditions are satisfied, payments can be made from one user's wallet to another user's wallet. You could say that, I've actually heard this comparison before, smart contracts are like vending machines. You put your payment in, you make your selection, and whatever you selected is dispensed. And here we can just take a look at a basic transaction with a smart contract. So this right here is how a typical contract functions now. There's some kind of an agreement. A contract is in written form. There's some kind of a third party, like a court or implied third party, and then there's execution. Or this could be a title company, a court, several different entities could be a third party. But with smart contracts, there's no need for the third party. So there can be an agreement. Smart contract can be written, and then it can execute. So here, parties can work with a smart contract peer-to-peer, sell assets such as homes or automobiles. So smart contracts can function as multi-signature accounts, and they can enforce the rules again to require that payments are made. They can run autonomously. They provide trust and reliability and also backup. They can reduce transaction time as well and then store information about the assets, such as, and an asset can be a domain registration, they can be information, it can be hard assets, it can be any type of. So if we look here for the modeling for a distributed application. So a distributed application is a smart contract running on a blockchain, but it is running in a distributed manner. So it's running on the network, on the operating network. So it's distributed on all of the nodes. First, we have the logic development. Then we have, in this case, it's Ethereum. EVM is Ethereum virtual machine, compiles the code. Then there is private and public key management, and then there's an update of the Ethereum ledger. Again, here is another example of a distributed application with a smart contract. In this case, this again is the escrow model. So here, Sandy needs an outdoor light installed. She hires Sam, and they agree to use a smart contract. Sam completes the tasks, then the smart contract will pay him. So Sandy uploads her Ether to the escrow. And then as certain conditions are met, Sam can get paid. So after Sam runs the wire, he gets some kind of a payment. And then ultimately he installs the light and payment in full is completed. To develop a smart contract or any kind of distributed application, you need some kind of a development environment. Remix is a quite impressive development environment for Ethereum. So Remix is a browser-based IDE for Ethereum smart contract development. Since it's browser-based, there is no installation, and Remix executes on typically on what is called a JavaScript environment that simulates an Ethereum blockchain. You also can use what's called a W3 or a Web3 provider, and Remix is, like I said, quite an impressive editor, and it provides the syntax highlighting, compiling, deployment, and visual debugging. So when you navigate to the URL, you can see the Remix development environment and its various what they call modules or views. We have our editor here, which you can see the syntax highlighting. And one thing about second generation blockchain smart contracts are assets can be built that model real world objects. So attributes that model these real world objects can be built in. So in this case, we can set up a clock asset. You can give it an item number, a color, a type, and these assets are transacted on the blockchain in the same way the blockchain's native token would be transacted. So we can see here is actual code that would describe the customer. Now it's up to us. Here we can see the customer's first name, last name, email, and their Ethereum wallet address. And we can see a function that will pay that customer, or maybe the customer will pay us. And we can define how we actually manage that customer. So here, the status of a customer, we could see here, we can build up customers in what we call a data structure here. And the payments will be made again as job status is completed. So there is a way to mark something as complete. If you look closely there, you can see job status as complete again, and then we can run through and we can see here there's a payee and a receiver for our smart contracts. And we can see here that there are ways to update certain status so we can decide if certain conditions are being met. And there's ways to pass this back to this smart contract. The nature of blockchains may not make it attractive for businesses. However, the public, when a blockchain is public, maybe a little bit less attractive for business, let's say. But many blockchains have a single ledger. However, a second generation blockchains can be multi-ledger. So Hyperledger Fabric is one such product that has multiple ledgers. And we already talked about private and permissions blockchains such as Corda and Ripple. And these new blockchain solutions remove the public permissionless aspects. So here we talked about first generation blockchains, second generation blockchains. I just want to quickly go into show a demo of a smart contract. So here we have our smart contract. This is called inventory list. And we have an item right here that we call item, and we're giving the item attributes. So in this case, we give it an item ID, we give it some kind of content like a name, you can see that here, and then whether it's present in inventory or not, and that'll be true or false. And you can see here that we begin, as items come in, we can add items to our inventory list, and we can mark them as present in inventory or not. And that's what this is doing here. So what we'll do is we'll compile it. So this is using Remix. Click our compile module here. Click the compile button. And that compiled. That's great. And then we'll go to our deployment module. And this is where we are running in what's called the JavaScript virtual environment, where we have a simulated Ethereum node. And here are all of our addresses. So you can see here are all of the addresses, and they're truncated, but they also have some test ether associated with them. And so here we only have one contract in the whole file. That's fine. Click the deploy button, and from this list we can see here we can create an item. Well, suppose I want to sell an item called iPad or iPad 2. Or iPad Pro. Let's make it iPad Pro. And you got everything there. iPad Pro. And so let's create the item. And so now that's been assigned an item count. Let's click on item count, and we see we have 11 in here. Let's see what our number 11 is. It should be our iPad Pro. Let's click items. And there it is, iPad Pro. So that was assigned the ID of 11. Now, how can I say whether it's in inventory or not? Well, I do this toggle present. Because right now, notice the status is false. So we don't have it in inventory. Maybe we're expecting it to get it. We don't have it in yet. But we know it's ID 11. So let's put that in there and let's toggle it. And let's click on here, items. Now notice it's true. So now we have that item in inventory. If you think about it, what else can we add to this smart contract? Maybe the actual number we have in stock. Maybe that would be something else worthwhile having. So please, please look over the assessment. And again, if you need additional resources, please consult your learning materials. And if if you need more training, again, please consult your training materials. Next session, we'll talk about popular blockchains. Thank you.